Hello and welcome to the video. This is the latest in the motor and prop series. I'm going to be speaking to this gentleman called Marcus. Say hello, Marcus.
Hi together. Hi, how are you?
And Marcus is the gentleman behind both the eCog website, which is a fantastic resource that you can go on and plug in your motor and prop setups for the particular fixed wing that you have, and it'll figure it all out for you. But actually, eCalc does a lot more than that these days. And Marcus is also the gentleman behind the Leo Motion Store, which is a European reseller of lots of really cool power systems for fixed wing models. Now, Marcus and I have been talking about this model that we've actually created. Not a model in the sense of it looks like a Spitfire or a Cub or a flying wing. More, it's a theoretical model that kind of explains something that we've been talking about in the past 3 videos. Now, if you have been watching the motor and prop series, you will know that we did 3 videos. One talking about how to make your plane fly faster, one about how to make your plane fly for longer, and one about how to make it easier to launch. And that is giving your power system on your model more thrust, more top speed, or more efficiency. And the issue with that is that as you strive for more efficiency, you're going to sacrifice top end high speed, and you're also going to sacrifice some of your static thrust. Similarly, if you want lots of static thrust to make it easier to take off, to hand launch, and to maybe to do things like prop hanging and 3D acrobatics, then you're going to have to sacrifice efficiency, and you're going to have to sacrifice speed as well. So Marcus and I thought it would be useful to kind of put this one together. And it kind of goes with those original 3 videos and hopefully provides the context. So as you watch those other 3 videos on how to fly faster, longer, and make it easier to launch, it kind of makes a little bit more sense. So I'll kick us off and talk about this quadrant down here. Let's talk about how to make your model fly faster. Now, that is pretty straightforward stuff. You usually use a higher kV motor, use a more aggressive prop, higher voltages. Those are the kind of things that pilots will commonly use, and that will result in a much higher top speed, a higher prop speed. Now, the issue with that, of course, is that lots of pilots these days like to fly nice and fast, and that's absolutely fine, but because you're sacrificing so much efficiency, you're only going to fly for a very small amount of time. As one of my friends says, it's half the time but twice the fun, and you're also going to sacrifice static thrust as well. So that model potentially is going to be harder to launch because the aggressive pitches that you are using on the propeller means that in still air it's going to stall, which means that you're not going to get all of the static thrust you think you do until the plane actually starts moving through the air out of static air.
For example, thrust. So thrust is very important for hand launching, as you already mentioned. And it gets also very important when you're doing 3D flying, so aerobatics with standing elements, then you require a lot of static thrust.
So the last one to think about then is the one at the top, and that is efficiency. If you want an efficient setup, then you are going to have to sacrifice top end speed. It's going to be a slower model, and you're also going to have to sacrifice some of the static thrust, the stuff that makes it easier to hand launch, take off, and also do things like prop hanging and 3D acrobatics. And when you kind of think of it, that kind of makes a lot of sense, because if you want a really efficient model, you're not going to expect those things. Now, efficient models are typically going to have larger props spinning more slowly, so it's going to use lower kV motors, particularly if you are going for endurance and you're using a larger LiPo battery like a 6S battery, because the more cells you add into a battery means that to produce the same wattage, which is the voltage times the amps, as the volts go up, the amount of current that you need goes down. So there are lots of tips and tricks to get more endurance out of a model, as well as just the motor and prop that you select.
Yes, there are some physical limits we have to respect. So when we are aiming to push towards one of these 3 edges of the triangle. So for example, when we are pushing towards thrust, we cannot neglect the fact that we need certain airspeed to stay in the air. So that is defined by the stall speed of the airplane. And normally I say we need twice the pitch speed of the stall speed. So when your airplane will stall at 30 kilometers an hour, then you need at least 60 kilometers an hour of pitch speed. That's one limit. The other limit is the thrust weight ratio. So it's very hard to fly an airplane below 0.4 thrust weight ratio. So let's say you have a 1 kilogram airplane, you need at least 400 grams of thrust to stay in the air without having problems to control the aircraft. And efficiency, there is a limit regarding the power system. So we have an efficiency curve, so I can show you. So here we have the characteristic of a motor when operating at full throttle. The blue line you see here is the efficiency, and we have to make sure the maximum efficiency is about here at, let's say, 4 amps around, and we have to make sure our maximum amperage is on the right side of this peak efficiency, so in this area here. Otherwise, when you're reducing the thrust, you come very fast in a curve where the efficiency will be reduced. So that's the reason why I always say stay right of the maximum efficiency.
So hopefully that's explained a little bit more about how efficiency, high top speed, and also thrust go together, and how you have to sacrifice one or two of them to get the third. And hopefully it helps you understand why those 3 original videos that Marcus and I did, one, how to get more top speed, how to fly for longer, and how to make it easier to launch, are built that way around, because that kind of gives you an idea of which way you're going to push it and how you can push it in your motor and prop selection to go towards the edges of this model. Again, a massive thank you to Marcus for the time and effort helping create this model and explain it this morning. But excitingly, there is another video in the works that's coming soon where Marcus explains his process for how, if you have a brand new model and you haven't got a motor and prop on there, maybe it's been glow, maybe it's been an IC engine in the past, maybe it's a brand new build and you don't sure what to put on it, what the tips and tricks are, the 4 or 5 steps that he goes through to get it pretty much spot on first time, every time. So make sure you're subscribed, hit the bell notification icon, and that will be out probably on Christmas Eve. Thank you for spending your time today watching that video. You can find me in all the usual places on social media, and if you're trying to learn about a subject, then check out the playlist. All of my videos are organised into easy to follow playlists that, if you're trying to learn a topic, will take you from the basics right the way through to some pretty advanced stuff.